Hi guys, welcome back from break. I apologize for not being here today. I am at a funeral, so please behave for the sub. I know they're going to do a great job for you, okay? A big thank you, first of all, goes to those of you who filled out the different questions for homework passes over the break. That's over now, so if you did that, I will be giving you your homework passes tomorrow, just to kind of give you a heads up on that. One of the questions was, what could I do different this coming semester to help you out a little bit? And I got some really good answers, and I will be trying to implement some of those over the next few weeks and few months. Okay, so we're going to kind of ease back into algebra as we do sometimes after break, and we're going to talk about inverse functions. Okay, inverse functions are something you should have seen in Algebra 1. Real basic stuff, but it's been a while, longer for some of you than others. So, like I said, I just wanted to ease back into this, okay? Here's a list of ordered pairs, and I'm telling you that this is a function. You could also tell me that this is a function, because you notice that none of the x's repeat. Since none of the x's repeat, you know this is a function, okay? And I'm saying, here's a function, and I want you to tell me the inverse of this function. Well, anytime you're trying to find the inverse, the very first thing that I want you to think of is I want you to switch x and y. Switch x and y. That's what I want you to do. So if you're given this point right here, 1, -3, and I need you to switch x and y, well, that becomes -3, 1. I didn't change the signs. I didn't do anything other than switch places of x and y. Well, it seems little silly then to try to ask you questions about what these are if you know that all we're doing is switching the place of x and y like this. Then we should do the same thing on this point too, right? So then that should be 3, -2. And if we're switching x and y on this point as well, that would become 1, 5. And if we're switching x and y on this one as well, that's going to become 4, 6. And that's it. When you're given a list of ordered pairs and you're asked for the inverse of that list of ordered pairs, all you do is switch x and y and you're done. Now, sometimes they'll say, well, you knew this was a function already because none of the x's repeat. I want you to tell me if the inverse is a function. Well, once again, we're just going to look and see if any of the x's repeat. Now, some of you might get confused by this because I got a +3 and a -3, but those are not the same. So, because those are not the same, none of the x's are the same, so that is still a function. Now, you're not asked that all the time, but I'm just making you aware of something that you might get asked. On your homework, all you're asked to do is find the inverse, period. And if this is the function you're given, that's the inverse, period. You're done. Okay? Another situation you might see is an equation. Y equals 3x plus 2. Well, the directions are find an equation that's the inverse of this. Well, how do you find the inverse? Switch x and y. So the first thing I want to do is switch x and y. X equals 3y plus 2. Now, there's nothing really wrong with that as far as the answer goes, but if we want to do anything with that, we can't leave it in this form. So if we're given an equation, we're going to switch x and y, and then we're going to solve for y. Get it in a form that we're used to seeing and using and all sorts of stuff like that. Okay? So if I want to get y by itself, first thing I need to do is subtract 2 from both sides. So x minus 2 equals 3y. And if I want to get y by itself now, what's the 3 doing to the y? It's multiplying. So to get away, we do the inverse operation of that, which is divide. So there's two ways I can write my answer here. I can write x minus 2 over 3 exactly as it looks like this. But you also know if I'm dividing this whole thing by 3, then I'm dividing each specific term by 3. So I could write y equals 1/3 x minus 2/3. Again, depending on the situation, we would want either one of those would work. Either one of them are correct. Okay? But again, We start with the fact that we are switching x and y to find an inverse. If it's an ordered pairs, if it's a list of ordered pairs, I switch x and y and I'm done. If it's an equation, I'm going to switch x and y and solve for y. Okay, let's do another example. Y equals negative 5/8 x plus 10. So the first thing I'm going to do, switch x and y. X equals negative 5/8 y plus 10. Now notice I didn't do anything to it, to the problem, except switch x and y. I haven't changed any signs, I haven't moved anything around, I've just switched x and y. Okay? Now if I'm going to solve for y, I want to get y by itself. So I've got to subtract 10 from both sides. X minus 10 equals negative 5/8 y. Excuse me. Remember that if I have a fraction, I don't really divide by fractions, because we just don't really do that. That makes a lot of mess. What we want to do is multiply both sides by the reciprocal of that number. Well, the reciprocal of negative 5/8 is negative 8/5. And if I multiply that side by negative 8/5, I multiply that side, the whole side, by negative 8/5. On the on the right hand side, negative 5/8 times negative 8/5 is 1. That's why I multiply it by the reciprocal so that I get a 1 there. So I end up with just the y. On the left hand side, I distribute. Negative 8/5 times x is negative 8/5 x. Negative 8/5 times negative 10 would be negative 10/1. So I could either multiply it straight across and then divide to see if there's any common factors, or I can simplify as I go, where that would be a 1 and that would be a 2, and all I have left is negative 8 times negative 2, which is 16. Now that y is solved for, that is my answer. That is my equation. That's the inverse of my original equation. And then we're done. Okay, so once again, how did I find an inverse? Switch x and y, and since it's in an equation, I solve for y. Okay? Now, they're not all linear equations like the first two equations that we've done. Sometimes they may be like this, which you know would be a quadratic equation. Okay? So, let's go ahead and start. What do I do first? Switch x and y, and then solve for y. Okay, so switching x and y, I get x equals y plus 3 squared. Now, so do I subtract 3 from both sides first? Oh no, I can't do that? Oh, you're right, because the 3 is inside the parentheses, so I've got to get rid of the parentheses first, but I can't get rid of the parentheses first till I get rid of the squared. Now, so here's our first big problem that we have to face. Okay? I got to get rid of a squared. How do I undo a squared? How do I undo a squared? Well, I undo a square by taking the square root. So if I square root this side, I have to square root that side. So I end up with the square root of x equals, well, if I'm taking the square root of something being squared, I just get what was in parentheses to begin with, the y plus 3. Now, if I'm truly trying to solve for y, all I have left to do is subtract 3 on both sides. Be very careful about where this 3 is, because the 3 is not inside the root sign, it's outside the root sign. Make sure it's very obvious. Now, I know I just threw some of you off because the y was on this side and I moved it on this side. Is everybody okay with that? Good, okay. This came down, I could have had square root of x minus 3 equals y, but those two things equal the same thing. Okay? And that's my answer. I solved for the inverse by switching x and y and then solving for y. I undid the square by taking the square root, and then I subtracted 3 from both sides. Okay? Again, like I told you earlier, they're not all linear. And in this case, they're not all squared, so I'm going to do a problem like this for you. Hopefully you can kind of see where this is going. So what's the first thing that I do? Switch x and y. So this becomes x equals the square root of y minus 7 when x is greater than or equal to negative 7. That's a boundary. That's a thing that we have to take into account. It's specifying, in this case, it's specifying a range. Excuse me, when we find the inverse, now it's not specifying a range. See, it had y before. Now it's specifying a domain because now it has x. Okay? But looking just at this original equation, if I have to solve for y, first thing I have to do is add 7 to get the 7 away. And I get x plus 7 equals the square root of y. Now I have to figure out, how do I undo a square root? Well, hopefully you remember, to undo a square root, we square. But I'm squaring this whole side, remember. Okay? So y is going to equal x plus 7 squared. Now, unless it specifically wants you to multiply this out, you don't have to multiply it out. Okay? You, of course, would know that if we were going to multiply it out, I do x plus 7 times x plus 7, and I distribute and stuff like that. But like I said, depending on the situation, unless it explicitly says to multiply that out, you can leave it like this, because that will help you with our transformations. We know it's a quadratic, so we know it's a parabola. We know it's inside, so it's going to move left or right. It's x plus 7, so we know it's going to move left 7. Okay, that would help a whole lot more than having the x squared plus 14x plus 49. Okay, if we were trying to graph it. So those are the kind of problems that you're going to see on your homework. Okay, on the first part of your homework. The second kind of problems you're going to see are problems like this. So far, we've had problems like this first one that we did, where we had a list of ordered pairs and we wanted to find the inverse, and you know we would switch x and y and solve for y. Okay? Then we had problems like this, where we were going to have an equation where we would switch x and y and solve for y. Okay? I think I said solve for y over here, but we don't have to do that. We just leave it like that. Okay? But here in an equation, we switch x and y and then solve for y to find the inverse. Well, what do you think we're going to do if we have a graph? Does it make sense that we would switch x and y and graph the new function? So it's a whole lot like the list of ordered pairs here. Okay? A whole lot like the list of ordered pairs here. Well, this ordered pair right here is 1, 2, 3, 1, 2, 3, 4, 5, 6. 3, 6. So what point should I plot that would give me the inverse of that point? Yes, 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, so this is the point 6, 3. The inverse of that point. Well, this point right here is 2, 1. 2, 1. So what am I going to graph that's the inverse of this point? Good. 1, 2. 1, 2. Okay, this point is 1, negative 2. So the point I would plot that's the inverse of that point is negative 2, 1. Negative 2, 1. Oh, look, it's that point right there. That's so nice. Negative 2, 1. This point right here is 0, negative 3. So negative 3, 0 would be the inverse of that point. Excuse me. This point is negative 1, negative 2. So negative 2, negative 1 would be the point I would plot there. Right there. This point, negative 2, 1 would be 1, negative 2, and I already have that plotted right there because they were inverse of each other. It's interesting. And then this point up here is negative 3, 6. See? 1, 2, 3, 1, 2, 3, 4, 5, 6. So the point I would graph up here would be 6, 1, 2, 3, 4, 5, 6, negative 3. Now, if I plot those points, and I will, so you can see them, connect them, they are, it's that right there. Okay? Now, one of the questions I asked you before, and I told you might be asked, is the new function, is the inverse of function? Is the new graph a function? Well, in this case, hopefully you can tell that it's not. And just as a reminder, it does not pass the vertical line test. Because right here, it's touching in 2 different points. Okay? Now, that doesn't mean there's something wrong with it or it's weird or anything like that. It just means it doesn't happen to be a function. What I do want you to notice is this line right here. Can you tell me the equation of this line that I'm drawing in here as a dotted line right here? What's the equation of that line? Crosses at 0, 0. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. And so on all the way up to the top of the graph. So the y-intercept is 0 and the slope is 1. So the equation of that line is y equals x. Now, if I folded this right along the line y equals x, you would notice that these two functions are right on top of each other. You see that? See how they lie right on top of each other? That is proof that they are inverse functions when they lay right on top of each other like that. Now, tomorrow we'll go over this just to make sure, but it's real easy if you actually fold it and then hold it up to the light. Can't really show you that on the video right here. Camera doesn't do that very well. It doesn't see through paper like you can when you hold it up to light. But I encourage you, if you're struggling with this, go ahead and fold it right on the line y equals x, and then hold it up to light, and you'll be able to see that the functions are lying right on top of each other. Okay? So that's something interesting. Why do you think that's true? Why do you think that happens? Why do you think the line y equals x is so important? What have we done to find an inverse function? Well, we've switched x and y. I made y equal to x, and I made x equal to y. I made them equal to each other. And then I solved for the other one. So hopefully it makes sense to you. It's logical to you that these two equations in this case would lie right on top of each other, right across. They reflect right across the line y equals x. Okay? So that's your lesson for today. In a moment you're going to, let me do one more. Let me do one more of the graphing ones. Okay? Here is, let me draw this line real fast. Here's one more function I wanted to show you, and it's a linear function in this case. Okay? So how am I going to find the inverse? Well, I'm going to go to each point and find its inverse. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So this point is -4, -8. So I need to graph -8. 1, 2, 3, 4, 5, 6, 7, 8. -4. 1, 2, 3, 4. This point is -3. 2, 3, 1, 2, 3, 4, 5, -5. So I would need to graph -5. 1, 2, 3, 4, 5. 1, 2, -3. All right, I forgot to write these. -8, -4, -5, -3. Let's see, this point is -2, -2. Oh, that's its own inverse, isn't it? If I switch x and y, I just still get -2, -2. Okay, this point is -1, 1. So I would plot 1, -1 by switching x and y. 1, -1. This point is 1, 2, 3, 4. So 0, 4. So I'd plot 4, 0. 1, 2, 3, 4. 4, 0. And then one more would be 1, 1, 2, 3, 4, 5, 6, 7. 1, 7. So it's inverse. Switching x and y, I would get 7, 1. 1, 2, 3, 4, 6, 7, 1. Okay? Now when I go to connect these dots, I get that. Now, can you tell by looking if those are inverses of each other? Well, if we put in our line y equals x, it sure would help, wouldn't it? Now, I don't know if you noticed this before, but I drew it with a dotted line. Because it's not really there on the graph, it's just something that helps us give us information. So when we draw the line y equals x, we draw it dotted. But we always define it y equals x, just like that. So we remember what it's for. So if I folded this along the line y equals x, could you tell that they would be right on top of each other? There and there. I'll do it real quick. Once again, you won't be able to see it very well because I can't hold it up to the light for you and show you. But you can kind of use your brain and be able to tell. Maybe you can tell a little bit. You can only see that dark one because the other one is right underneath it. See that? Okay. If these two lines meet, where do they meet? If these two functions meet, where do they meet? Well, they meet right there at that point. Just happens to be, you think it just happens to be along the line y equals x, or do you think that's by design? It meets right there, and it meets, kind of, I didn't draw very well, but it meets right there. Okay? It does meet right along the line y equals x. Okay? So that's something interesting as well, because that's where y and x are exactly equal. So that's where they meet along the line. Okay? So in just a minute, your substitute's going to pass you out a worksheet. If you don't mind, go ahead and do that now, because I like them to circle the problems. One of the suggestions that some of you made was for me to do more example problems like I do for you every time, but more of those need to come directly from the problems that I'm giving you for homework, just so you don't feel like I'm giving you easy example problems and then you have to do harder problems. So I want you to notice I did that today. Okay, I didn't do it on the worksheet, but the very first problem I did was problem number 1 on your worksheet, and notice that each of the problems that I did are on the worksheet somewhere, so that you can see that the problems that I'm doing are the ones that I want you to do, are similar to the ones I want you to do. Let's see, where's that one? Oh yeah, number 9. We did this one right here. And number 18. Oh, sorry, that's number 13. We did 13 right there. And we also did number 18. Okay? So all the example problems that we did for you today came directly off of your worksheet like you asked. Okay? Oh, the graphs too. Let me show you. Here's my graphs. I guess it's not exactly that problem, but it's similar to that one. And once again, it's not exactly that problem, but it's similar to that one. Okay? So I want you to go ahead and circle the numbers that I have circled to be the ones that you do for homework tonight. Number 2, number 4, number 6, 8, 10, 12, 14, and 16. Basically all the even ones that we didn't already do. Okay? Don't worry about these. We're going to work on some tomorrow. Okay, so I don't want you to try to do any of these for extra credit or anything unless you just really want to try, unless you know how. I haven't showed you yet, and I won't show you till tomorrow. On the back, I want you to also circle 26 and 27. Okay? I will be back tomorrow, unless something happens that I don't know about, but I'm planning on being back tomorrow. I'll check this homework at that time. You'll be able to ask any questions you need to at that time as well. But hopefully inverse functions was a good place for us to start, because it is relatively simple, because all we're doing is switching x and y's. Remember, on ordered pairs, all you need to do is switch x and y, and then you're done. Remember, on finding inverses of equations or relations, you're switching x and y, and then you're solving for y. And then remember, on graphs, you can go ahead and graph it directly on the graph that's here. Figure out what point is already there. Switch x and y and graph the new point. Make sure you also graph the line y equals x on each of these that you're going to do for credit. It's been a long time since I've seen you, not since last year, so maybe some of you have forgotten that you're allowed to do the ones that are not circled for extra credit. Just reminding you. I hope you had a great break, and like I said, I will see you tomorrow. Have a great day. Peace.